Okay, so we're going to go ahead and show the experimental setup for experiment 4, which is really just to show how science is a predictive activity and that the basis of our knowledge is not only just our conception about how the universe works, but whether or not our conceptions can make predictions and those predictions do come true. So what we're going to do is we have a setup here, and we have track. We have a ball that made from metal, iron, that can roll down the track. It will pass through 2 timing gates. And the timing gate purposes is as the ball moves through the first gate, it sets up a timer to start operating. And then when the ball passes through the second gate, it stops the timer so we know the time of transfer from one gate to the other for the ball. We'll also take a ruler, and using the meter side, we measure from the middle of one gate to the middle of the second gate to get the total distance traveled for the time that we measure. Now, there's always a possibility of some error in measurement of time, and so in order to minimize that error, we actually take 3 measurements of the time. Now, what's the purpose of this? What we're going to do is by measuring the distance traveled by the ball, by measuring the average time it takes to move that distance, we can get the speed that is moving in a horizontal direction. Using that information, plus also measuring and using the ideas of motion, and knowing exactly how long it will take a ball to travel straight down from the edge of the track to the floor, getting that time, we can use it to predict where the ball will travel as it comes off and eventually hits the floor. And what we plan to do then is to go ahead and take a little target, you can see this, and place it on the floor and actually see if the ball makes it to where we predict it to be. Now, if you would be in class, you would be doing this. Obviously, with the pandemic and the fact that we're teaching at home, what we're going to do is take these measurements. We're going to go ahead, make those calculations for ourselves. We'll place this and we'll verify that the ball hits there, hits the target. Now, what you're going to do, and all the lectures that you'll have with your particular professor will show you how to do this, is how to make those calculations and those predictions so that you would know where to place the target yourself. And that's what you'll calculate. So, what we're going to do, number 1, is we choose a specific spot that we always drop the ball from, because we want consistency in how we operate this. We don't want to drop it here sometimes and there sometimes. That will affect the ultimate speed that it moves through the 2 timing gates as far as the ball is concerned, and that would affect our measurements and would definitely make our predictions inaccurate. So, what we're going to do is this. Let me just step it out. Number 1, we mark a spot. I'll use a piece of tape in a moment. Maybe I can just take a bit of this tape right here. We'll mark a point that we will place the ball always at. So I've got a piece of tape here, and on the edge is where I place that ball. I will allow the ball to travel down. I won't allow the ball to hit the floor. But what happens is I will stop it before then. And we'll take 3 measurements of the time it takes to travel that distance. And so to do that, if you want to go ahead and we'll film this little controller, the way that we operate this is that this is what's known as the interval method, which means it measures the time it takes to move from one point to the other. We have it in that position here. We reset both gates right here, so they're both green, meaning that they're armed. We'll have this at 0. And we'll go ahead and do this. I'll go ahead and remove this ruler. So, we'll verify that everything's set, armed, ready to go. We have this in the right position. I'll let it fall, and I will catch it, and then we record the time. So the time is 0.5 0.4966. Again, 0.4966. Then what I do is I go ahead and I reset this, the timer, which means I have to rearm the gates again. I carefully place the ball back in the original position with the tape marking that spot. And then I go ahead and stop it from hitting, well, not hitting out to where it would go. Remember, I'm a physicist. Don't put anything sharp in my hands. It could be dangerous. So we have this time, which is 0.4978. I go ahead and reset this again, retime this, reset, and then arm the timers. We'll let this drop one more time. And we'll catch that, and we get a third time, which is 0.4959. Notice that we take all the digits of the timer, so we go out to 10,000ths of a second on this, and we'll go ahead and we will carefully find the average of that. How do you find the average of three numbers? Yes, you add the three numbers together and divide by 3. And so that's something that you'll be asked to do. And so the next thing I do is I take the ruler and I measure the distance from the center of the timer, which has a mark, out to the center of the second timer. And I get, and we want to have this in terms of meters, 0.872 is that distance between the tracks. And there's one last thing we have to measure, and that is the height above the table. And so we take a little device that's well known. It's been really wrapped up well. I'll see if I can get this to unravel. Oh, I see. Been taped. There we go. Okay, so we unwrap this. This is a device called a plumb bob. As you can see, hi Bob. And so a plumb bob is a device that hangs directly down. You have a string with a weight on it, so gravity will pull it directly toward the center of the earth. And so I'm going to go ahead and measure from the center of the ball out, which is the center of the mass of the ball. I hang it very carefully. So I get the length of this. I measure that height. And so the height I get using the plumb bob, I put this at the end. I measure this out to be 0.76 meters. 0.76 meters. With this information, we have everything we need to know in order to make the calculations necessary for this laboratory. So we'll stop the video right now. We'll make our calculations and we'll show you how, if we place, first off, if we do the calculations correctly, and then if we place our target in the right spot, the predictive power of science will allow us, without ever trying to do it beforehand or any practice, and actually get that target such that the ball will move out and actually hit the center of it. Okay, so we'll stop there.